In this video, I introduce a robotics transformer for real-world control. Robotics transformer takes as input images and natural language instructions and outputs 10 discretized base and arm actions. The RT model treats the mapping of language and vision observations to robot actions as a sequence problem, which is learned by using a transformer. As shown here, this is the architecture of the model. This is a clip of images. This is a language instruction. A deep convolutional neural network uses this instruction and images as an input to generate the output feature maps. We use these features from the deep CNN as a token, and then the token linear reduces this number of tokens to a small number of tokens, and then transformer uses tokens as the input to generate the control actions. At time step t0, the policy pi is presented with a language instruction I and the initial image observation x0. The policy produces an action distribution pi from which an action A0 is sampled and applied to the robot. The goal of our RT model is to learn a policy that maximizes the average reward over the absolute XA conditioned on language destruction. RT model further maps input the instruction I, images X to a sequence she, and action token outputs AT to a sequence of control parameters Y. A transformer is then used to learn the policy pi that maps the input sequence to output sequence Y. The training dataset D consists of N episodes, all of which are successful with the final reward of Y. Behavior cloning is used to learn the policy pi by minimizing the negative log likelihood of actions AT given the images and language instruction. The RT model is built on a transformer architecture, which takes a history of images and task description as input and directly outputs 11 tokenized actions. A history of 6 images with a resolution of 300 by 300 passes through a deep convolutional neural network, and the output feature maps are 9 by 9 by 512 that are flattened as 81 visual tokens. As shown here, this input image, this deep CNN. We use the features generated by deep CNN as tokens that are fed into the transformer. The language instruction is encoded by a pre-trained universal sentence encoder, as shown here. This language instruction, this universal sentence encoder. And then image tokenizer is modulated by language instruction to consider the influence of the language instruction, as shown here. This one to preserve the pre-trained weights from a universal sentence encoder. This feature-wise linear modulation, as shown here. And this MB convolution is a mobile inverted bottleneck convolution, as shown here. This token linear that reduces the tokens from 81 to 8 per image. And then we use the reduce the number of tokens as input to the transformer. If ILM learns FC and HC to output gamma and beta as a function of input X0 as shown here, where gamma and beta modulate the network's activation F via feature-wise affine transformation as shown here. Token learner uses element-wise attention to learn to map 81 to 8 tokens for each image, as shown here. This element-wise attention and this tokenizer. It reduces 81 tokens to 8 tokens per image, which can select the image tokens based on their information and only allows the important token combination to pass through the transformer. The total 48 tokens from 6 input images with positional information are fed into a decoder-only transformer to predict the action tokens as shown here. These tokens from the token learner, and this positional information, and this transformer. This is the actions generated by the transformer, which includes a total 11 actions, 7 for arm movement, 3 for base movement, and 1 for switch. Across entropy loss is applied to train the robotics transformer. For more details, please check with these references. Thank you.